Hey, I want to go through this and one other problem on your homework. I've had some people express some difficulty with this question, so I want to take a look. Let me pull this over a little bit. Normally I write on alongside, but I'm just going to kind of talk through this, and hopefully you write down what's necessary. A lot of this is going to take place in the calculator too. So let's read the question first. A TV show, Lindsay and Tobias, recently had a share of 15, meaning that among the TV sets used, 15% were tuned into the show. Assume that an advertiser wants to vary that a 15% share value by conducting its own survey, and a pilot survey begins with 20 households having TV sets in use at the time of Lindsay and the Tobias broadcast. So what they are doing here is the TV company is making a claim that 15% of people are watching this TV show, and an advertiser saying, well, are they really? Let's go ahead and try to get some of our own data. So we're going to use a binomial PDF here. So we're going to use the binomial distribution. And the three things we need when we do a binomial distribution is we need to know n, which is the number of people who are involved in the survey. And you can see right here it says the pilot survey begins with 20 households. So this is n, is 20. We need to know the probability, and you can see that we're given 15% here because we're saying 15% of people are watching that, right? And then we need a value that we're looking for. And when you look at part A, it says find the probability that none of the households are tuned into this show. And so that x value, we're trying to find out if we test 20 people and the probability is 0.15. What's the probability that none of them are watching this show? So we're going to go to second and then the VARS, and we're going to scroll down. It might be 0, it might be A depending on your calculator, but just go down until you see binomial PDF. Hit enter. If you have a TI-83, you're just going to put the numbers directly in. How many households were we surveying? 20. What is the probability of success? The claimed probability of success is 0.15, and we're trying to find the probability that none of the households were tuned in. So that x value is 0. And when we run this, again, if you have an 83, you're just going to type in 20, comma, 0.15, comma, 0. So you just type it in directly. And when you hit enter, you'll see if there's a 15% chance of success, if you have 20 people and you're trying to find the probability that none of them are watching, there's a 3.0387 as a decimal, or 3.87% chance that this would happen, that none of the households are tuned in. So it's going to be, we're going to round this 3 decimal places, so 0.03, and that 8 is going to round up to a 9, right? Okay. What's the probability that at least one household is tuned into Lindsay and Tobias? Remember, the probability of at least one, you do 1 minus the probability of none. Again, go back and take a look. If you're not sure, you can take a look at the chapter 4 notes. I think it's in section 4.5. We talk about at least one probability. So if you're not sure about at least one, it's 1 minus the probability of none. We found the probability of none right here. So it's going to be 1 minus 0.39, right? Whoops, 0.039. So 0.961. So we just do 1 minus the probability of none to get at least one. Find the probability that at most one household is tuned into Lindsay and Tobias. What do we mean by at most one? Well, at most one would be the probability of 0 and the probability of 1, right? At most one would be 0 or 1. Notice we found the probability that none of the households was right here. We need to do another binomial PDF, and we need to find the probability that only one household was tuned in. We're going to do that binomial PDF. N stays the same, still 20, still 0.5, and this time just instead of 0, we're going to do 1. And let's run that. So there is a 0.039 chance that 0 of them did. There is a 13.7% chance that one of them do. So we're going to add those together. So it's going to be 0.39, or I'm sorry, I keep 0.039 plus 0.137 Again, we just add those two probabilities together because at most one is 0 or 1, and I get 0.176. All right. So if at most one household is tuned into Lindsay and Tobias, does it appear that the 15% value share is wrong? Why or why not? Well, look, we got pretty close to 15%, didn't we? So no, because with a 15% rate, no. I think it's going to be this one right here. No, because with a 15% rate, the probability that at most one household is greater than 0.05% chance. All right, let's take a look at another one. An airline has a policy of booking as many as 16 people on an airline when it can only seat 15. Past studies have revealed that only 87% of the booked passengers actually arrive for the flight. Find the probability that if an airline booked 16 persons, not enough seats will be available. So we want to know, when do we encounter a situation where there's too many seats? That's when we book 16 and then have 16 show up. So we're going to do a binomial PDF here where we have 16 people. The probability that they all show up is 0.87, and then that all 16 show up. So it's going to be 16, 0.1, 0.87, and then 16. So we're going to do this binomial PDF. You can arrow up, and sometimes that's a little faster than arrowing all the way down. How many trials do we have? We have 16 people, right? There's an 87% chance they show up, and we want to find the probability that all 16 of them show up. So what are the chances that this happen? It is 0.1077, where we're going to round that 4 decimals, so 0.1077, so about 10.77 chance. And that's it. So I hope these help, and if you have any questions, let me know.